All right, guys, so I'm going to try to explain this real quick just to kind of give you something to refer back to. First of all, of course, make sure you read all these boxes here and read what's going on. Things will make sense if you really read this and think about it. I mean, think about if the function is decreasing, like here, the derivative, which remember, derivative is slope of the tangent line. If I draw in a tangent line right here, the tangent line is negative. It's a negative slope. So if the function is decreasing, the slope of the tangent line is negative. If the function is increasing, the slope of the tangent line is positive. Slope of the tangent line is derivative. So that's what that's saying there. Okay, so let's take a look at these quick. Always pay attention when you're given the graph, what the graph is of. This is the graph of the derivative of f. So you really got to be careful with that. So number one says, does the function f have a min, max, or nothing at 3? So here's 3. That's where we're looking. We want to know the function. This is the derivative. So we got to use the derivative to answer questions about the function. In general terms, when does the function have a minimum? When f changes from decreasing to increasing, or when f prime changes from negative to positive. On the flip side of that, when does it have a maximum? When does f have a maximum, the function f? When f changes from increasing to decreasing, or f prime changes from positive to negative. There is a big difference between increasing and positive. Don't get those mixed up. If neither one of these things happen, then there's nothing going on at 3. Okay, so that being said, let's think about what's going on. Does f change from decreasing to increasing? Well, this is the graph of f prime. So we're not thinking that. We are thinking about this. Is the derivative changing from negative to positive? Is the derivative changing from positive to negative? So remember, positive means above the x-axis. Negative means below the x-axis. So at 3, is the derivative changing signs? Here it is. Is the derivative changing from below to above? No. So it is not changing from negative to positive. It's not a minimum. Is the derivative changing from positive to negative, meaning above to below at 3? No, it is not. So that's why the answer is neither. And I'm not going to really write in the answers because you can refer back to the answer key. I'm just going to try to explain as I go through it here. Okay? So that's what you're thinking. The key here is this is the graph of the derivative. Keep that in mind. Okay, so let's look at number 2. Let's see what's happening at 1. So when x equals 1, we're right here. So do we have a minimum or a maximum? Is the derivative changing from negative to positive or positive to negative? So let's see, at 1, what's going on? At 1, the derivative changes from negative to positive. Right here, the derivative is negative. Right here, the derivative is positive. So if the derivative changes from negative to positive, that is creating a minimum. So that's why it's a minimum. F, the function f, has a minimum at 1. Why? Because the derivative is changing from negative to positive. Again, using the derivative. Okay, let's look at number 3. What's happening at negative 2? So here's negative 2. We want to know, does the function f, well, what is the derivative doing? The derivative is changing from positive. And really, I'm just tracing it from left to right. If I trace this, it's positive, and then at negative 2, it changes to negative. So it's changing from positive to negative, creating a relative maximum. Okay, and again, you're always going to have to justify your answers. Make sure you look at the answer key and look at the justification on that. Okay, so same idea for 4 and 5. Let's jump ahead to number 6. It says, on what intervals is f increasing? The function increasing. So again, we're answering questions about the function, but we're using the graph of the derivative. So when is the function increasing? The function is increasing when the derivative is positive. The function is increasing when the slope of the tangent line is positive. So we look at the graph and we look, where is this positive? Positive meaning above the x-axis. So it's interval notation, -4 to -2, it's above 1 to 5. And we want to kind of indicate this critical point here when the derivative is 0. Read about the critical point above. So we acknowledge that 5 and then to 7. So that's where it's all positive. That's where the function then will be increasing. And then for number 7, we're looking where the function is decreasing. That's when the derivative will be less than 0. So we would come up here. Where is the derivative less than 0, meaning negative? We're looking below the x-axis. Where is the graph below the x-axis? From -1 or -2 to 1. Okay, so that kind of explains that a little bit. So then you're kind of doing the same idea here. Let's take a look at one of these here so you can see algebraically. If you're looking for, so this time you have no graph. This time we have an equation. The equation is of the function. If we want to know where the function has max and mins, we want to know where is the derivative changing signs. So you find the derivative, you go to the number line, and you look to see where the derivative is changing. If it changes from positive to negative, that's creating a maximum. If it's changing from negative to positive, that's where the function has a minimum. So that's what's going on there when you're looking at the answer keys. And then, of course, these are big. These are huge, huge, huge. In terms of the AP exam, you've got to be able to say these like the back of your hand. So read those, look them over, and let us know what questions you have. Okay, so I just wanted to give you a quick overhaul on that. Stay safe.